Another application that we have for these compilers are the format conversion. So, many times what happens is that we need to as I was telling that we have got two different software packages, and between the software packages the output of one software package should go to the as input of another package. So, accordingly we need to give some translation, because there may be the input output formats between the tools may not be compatible, particularly if they are coming from different vendors. So, in that case, so the software output that we have from one tool. So, if this is say tool 1, it takes some input and it produces some output, and then we have got tool 2, but this tool 1 output I need to feed it to tool 2, but it is not compatible. So, tool 2 it expects input in some format. So, it is very much common, particularly like maybe in tool 2 the input format. So, it does not take semicolons at the end of the lines, whereas tool 1 it produces semicolons at the end. So, like that. So, maybe tool 2 it requires variables to be defined in some fashion, whereas tool 1 output is in some different format. So, in those cases what is needed is that in between we put a translator. So, this is another compiler, and this translator produces the output which is understandable by tool 2. So, and it goes like this. So, this way we have some format converters, and this is very much common, particularly if you look into the CAD domain, VLSI CAD domain. So, you will find there are many such tools where we need to do lot of format conversions. So, this is compatibility between input output formats between tools of different vendors. Now, next thing is that also it is used for converting heavily used programs written in some older languages like COBOL to newer languages like C, C++. So, COBOL is a language, common business oriented language. So, that was used at one point of time. So, they were used very much, particularly for this office automation purposes, where we used to generate this payroll and all using these COBOL programs. Now, though this COBOL as a language is very much verbose, and it is the programs that runs in COBOL. So, they are not very much efficient as far as execution speed is concerned, but they are very efficient as far as file handling is concerned. On the other hand, today after that these languages like C and C++ came. So, now the new software that are being developed. So, they are not being done in COBOL, but in some next level programming languages or even in fourth generation language. But that point is there. So, there are large number of programs which were existing. So, this payroll software that we had. So, that was existing in some old language like COBOL. So, we need to convert, we do not want to make all those programs junk, rather we try to have some converter, so that we can automatically generate the C, C++ programs from those old COBOL programs. So, that way we have got we have to have these programs which are written in some older languages translated into newer languages. So, that is the role of format converter. So, so here also we have got the compilers in picture. Next we have got another application which is known as silicon compilation. So, silicon compilation is like this, that today suppose we are trying to design some new integrated circuit chip. For example, suppose we want to generate a new processor. Now, if we want to design a processor, now there can be two different avenues by which we do it. In one avenue, we start with the lowest level modules, like lowest level digital circuits like adder, subtractor, multiplier, register design, then slowly go up to the full system design. So, but the problem in this particular approach is that it is time consuming, and if the user is not very much careful. So, there is a possibility that some bug will get introduced into the process, and then the chip that is fabricated is not correct. On the other hand, so there can be another avenue by which we can handle this problem. is start with the behavioral description of the system in some language, hardware description language, which is like VHDL, Verilog. So, these are popular hardware description language in which you can describe the hardware in different levels. So, behavioral level, structural level, functional level, like that. So, at the top level we have got the behavioral level description. So, you can describe the behavior of the processor in terms of this language constructs, and then from there we try to generate the circuit. Now, you see here the input to the system is a description in some VHDL or Verilog language, and then the output that we have. So, if this is the silicon compiler, so here you have got this VHDL code as input, and as an output you do not have machine code, but rather you have got some other you have got another VHDL code, which is basically a structural level description, which we call netlist. So, this is a netlist of this library components that we have. So, so that netlist So, that netlist that we are talking about. So, this netlist is nothing but it is a collection of hardware modules that will be making this whole system. For example, in your system you will need adder, subtractor, registers, etc., and some connection pattern between them. So, this netlist will be a connection, it will having all those module descriptions, and it will have the connections between them. So, this thing is automatically synthesized. So, so user does not design the individual adders. So, they are designed previously and available in the library, and it is taken from there. So, that way it is done. So, for very complex systems, so it is so this is the way that we should proceed. We should start with the behavioral description and then convert it into the netlist depending upon some library modules. So, this is known as the silicon compilation process, and this is also some sort of compiler. So, complexity of circuits increasing with reduced time to market. So, this is the pressure that we have. So, every day we are coming up with newer and newer systems, electronic systems that have got more and more functionality into it, and there is a very high pressure on time to market. Like if we survey the market and see that we want to introduce a new cell phone into the market, then maybe if it is introduced within next 6 months, there will be some benefit, some profit, but if it is introduced after 1 year, maybe that profit will be half, and if we introduce after say 1.5 year, maybe the profit will become 0. So, that way there is a very high pressure on this on reducing this time to market. So, here if you are starting at the lowest level and trying to generate the whole system very efficiently, so it will take time. So, we go in the other way. So, we start with the high level description, behavioral description of the system, and from there try to come to the circuit. And the optimization criteria they are also different. Like when you are writing programs for execution by a processor, then the optimization criteria there is the speed of execution. Then you have got this what is the memory requirement. So, these are actually the optimization criteria, but when you are doing silicon compilation, so the optimization criteria is the overall area required by the circuit, the power consumption of the circuit, the delay that the circuit will have. So, we want to reduce this area, power and delay. So, the measures that we have are totally different. So, a compiler which is targeted towards say machine code generation will not do well if you put it onto a silicon compilation process. So, the challenges are totally different. Next, the other application that we have is in the domain of database query processing, which is known as query optimization. So, in database you know that a major operation that we have is to answer the user queries, and once the database has been created, its content is more or less static. For example, if you look into the database of an organization, in the employee database of an organization, so initially there will be additions and all, but after some time, after the database has been stabilized. So, it is not that every day lots of employees are joining the companies and leaving the company. So, that way that database is more or less stabilized or more or less static in nature, and the queries that you get on the database are like this. Maybe it is trying to find out the average salary, or every month we have to do salary processing and all that. So, the queries are much higher in terms of some information, getting some information from the database, but the basic data value changes are much less. Okay. So, it is very much important that whenever we have got these queries, so these queries are to be processed and they are to be answered quite fast. Now, how to reduce this search time? So, if you look into the database theory, you will find that there are depending upon the size of the tables that we handle. So, we can manipulate the tables in certain order to reduce the overall time requirement. So, given a query, what is the exact sequence of operations that we should do on the database for finding the answers quickly? So, that is a big challenge, and that is known as the process of query optimization. So, that is also some sort of compiler, because you see that the given the query in some high level language like say SQL and all. So, converting it into some file operations. So, ultimately it is doing some file operations. So, ultimately the operating system file routines are to be called. So, how this translation will be done? So, that is a big question, and we have got these compilers to help us. As it is noted here that we want to optimize the search time. So, more than one evaluation sequence may be there for each query, and the cost depends upon the relative sizes of tables, availability of indexes, etc. So, the same query, if the table sizes are different, so maybe if you process in different sequence of operations, then the timing requirement will be different. So, as a result, so we definitely do something, so that particular ordering has to be found. So, the size of the tables will dictate like the sequence in which the query should be evaluated. Should generate proper sequence of operations suitable for the fastest query processing. So, that is very important. So, here the optimization is not in terms of so the space requirement or that execution time, but it is in terms of the retrieval from the database. Like if you know that these are file operations. So, whenever we have got file operations involved, so that file operation take very high amount of time compared to the processing. Like once an employee salary record has been retrieved, so maybe we just want to increase the basic pay by some amount. So, that operation is just an addition operation or at most another multiplication operation, but the major time is spent in getting the record from the secondary storage. So, the optimization that we have is in terms of the number of disk accesses and all. So, the optimization criteria is totally different when we are going for database operation compared to the situation that we have for say this code say execution of normal programs. Okay. Another very interesting application that we have for compilers is in the text formatting. So, there are many tools by which you can format the text files. Like today you know that there are many such formatting tools. For example, we have some of these so these formatting tools that we have. So, they can be classified into two categories. Sorry. So, these formatting tools that we have. So, this text formatting, some of these tools. So, there what we are doing. So, we have provided some sort of graphical interface, and in that graphical interface the font and everything is designed, and we just choose the appropriate font and enter the text in that format. So, immediately you get a feedback like you are writing in such and such font and with font size and all. So, you immediately get an understanding like how is it looking like. So, you can choose some other format, you can make some part bold and all by doing it immediately onto the text. In some other format, so it is like this, that if you just write a file and in that file you put your normal text, and before this text you put some and also embed some formatting command in it, some formatting command you put into it in the same file. So, in this case what will happen is that, so now this whole thing is given to a compiler, and the compiler So, it applies these formatting commands on this text and then it will be converted into a formatted text. So, here in this, in case of graphical thing, what was happening is that you are immediately getting this formatted text and as a visual output. So, you are just looking into that. But in case of this one, so this file that we have is nothing but a simple text file, and this simple text file is converted by means of a compiler into a formatted text file, where this formatting commands are taken care of. Like this formatting command, maybe it will tell that the next few lines I want to make italics. So, accordingly it will do that. So, it has got many advantages, because the portability of this file is very easy. So, because this is a simple text file, so you can very easily transfer and all, and you can so after some practice and experience. So, you may find that these formatting tools are much better compared to these graphics based tools. Okay. So, this text formatting tools, so they come under this compiler. So, this is also some sort of compiler, because you are accepting input in some text file format and then as an output you are producing this graphical thing. So, that is also a text formatting. So, these text formatting tools, so they accept ordinary text file as input, having formatting commands embedded into it, and it generates the formatted text. And so, these are some of the examples, like so in Unix operating system you have got trof, trof, nrof, and there is another very well known package which is known as latex. Okay. So, which are used for doing this type of translation. So, they come under the broad heading of formatting tools. So, that is also a type of compilers. Next, we will look into the phases of a compiler. So, you see that if I have got a big job to do, like this translating from one language to another language, maybe high level say C language to target machine code, or say some a VHDL to this silicon output, or say this formatting tools, text formatting tools, or whatever application we think about. So, this transformation process is quite complex. So, ideally I have a monolithic piece of software which is doing this translation. The compiler appears to be monolithic, but in the design phase, just to make this compiler design process simpler. So, we can think about it to be divided into a number of phases, though practically speaking. So, there is no hard demarcation. Okay. So, these modules are there, they are not demarcable clearly, but for our understanding, for our discussion in the course. So, we will be dividing them into number of phases. Okay. So, the first phase is known as the lexical analysis phase. So, to start with, so before going into this, so let us try to understand, like if I have got some language, for example, if I have got the language English. Okay. So, any language, so what we have immediately is the first thing that we have is the alphabet. Any language starts with the alphabet. Now, you know that in English language the alphabet set is, say, this capital A, B, etcetera up to capital Z, then this small a, small b, small c, etcetera up to small z. Now, there are many more symbols like this 0, 1 to 9, then whatever special symbols that we are allowing in, say, today's English language text. So, they all come under this alphabet set. So, for any language it starts with the alphabet. Okay. So, we are having the alphabet. Now, once we know the alphabet set, so this is commonly represented by the symbol sigma. Okay. And then this alphabet, some of these symbols in the alphabet, they are combined to form words. So, this alphabet, so from the alphabet we get words. Word is nothing but collection of alphabets, and it is separated by some special say separator. For example, in most commonly we are using the separator blank, okay, for English language sentence. So, this word, so word, so any collection of alphabet you take, okay, so so that is a word. Now, this word may be a valid word may be an invalid word. So, word you can classify into two categories, one is the valid word and another is the invalid word. For example, for English language cat. So, this is a valid word as far as we know, but say CTA, this possibly not a valid word. So, I am not very much knowledgeable in English language that way. So, I cannot say very clearly that whether CTA is a valid word of English or not, but assuming that it is not a valid word. So, it goes into the invalid category. So, that is the second thing that we have. So, alphabet set. So, if there is a so if my English language is does not allowing the Greek symbols like alpha, beta, etc., then if I get the symbol beta somewhere in the text, then I will say okay, this beta is a is not in the alphabet set. So, there is a problem with the alphabet, but even if the alphabet part is correct, the CTA is not a valid word. So, that is another level of invalidity. The next level of invalidity that comes like when we consider the sentences, when we consider a sentence. Now, sentence, so it is a collection of word. Now, if we consult the grammar of this English language, grammar of the English language. So, there are certain rules which will tell us like what are the valid sentences, what are invalid sentences and all. So, it is a very huge process, or I should say very complex process to say whether a statement that I have made in English language, whether it is grammatically correct or not. But anyway, so if we take some simpler language, maybe the grammar rules will be simple and it will be very it will be easy to tell given a sentence whether it is whether it is valid for the language or not. So, accordingly you can say that this language this sentence, it can also be valid sentence or it can be invalid sentence. Now, this if a sentence is valid sentence, we say that the sentence belongs to the language. If the sentence is an invalid one, we say that it is not belonging to the language. So, that way we can have this for a language, it starts with alphabet, then goes to words, then goes to sentence. At each level we have got the issue of validity and invalidity. So, in the lexical analysis phase, so what we will try to do is to see whether we have got some valid word or not. So, alphabet we can check immediately. So, whether there is any foreign character that are present in the description, and if there is no foreign character. So, it will try to see like what are the words of the language that are appearing in the program. So, accordingly it can determine the words. So, it can it will do the processing and it will find out the words. So, that is the job of lexical analysis. Once this lexical analysis is done, we have got the phase of syntax analysis. So, in the syntax analysis phase we do the grammatical check. Then we have got semantic analysis, where we try to find out whether there is any problem with the meaning, like maybe some variable is undefined and all that. So, that is the semantic analysis phase. Then we have got some intermediate code generation phase. So, up to the semantic analysis phase, so or the syntax analysis phase, you can say. So, this is based on automata theory. After that, whatever we will have, so they are more they will be using the outcomes of this automata theory based analysis, but they will be augmented significantly by means of other techniques, so that we can do the code generation part. The first phase of that is intermediate code generation, then that intermediate code is translated into target code. So, that is the target code generation. Then after the code has been generated, so we can stop there, but most of the compilers they will go into a code optimization phase. So, since this is the entire process is an automated process, so there is a very high chance that the code that is generated by this code generation process is not optimized significantly. So, it will be optimizing it, and then maybe we will be getting a faster code for that. So, that is the code optimization phase. So, apart from that, there are some other points which are also important for compiler design. One is the symbol table management. So, symbol table is a table of all the symbols that appear in the program, all the variables, procedures, labels that appear in the program. So, they come under the symbol table part. So, the symbol table has to be managed, because many times the compiler module, so they will refer to this symbol table for the checking and code generation process. So, they will do that. And we have got another very important phase which is known as error handling and recovery. So, whenever there is some error in the source language program, then this compiler has to detect it, and after detecting it, it has to proceed. Like if there is an error at line number 10, then it is not advisable that the compiler just prints that there is an error in line number 10 and comes out. Rather, it should check the remaining part of the program also and come up with a list of all those lines. So, where the compiler thinks that there is an error, maybe there are errors at line 10, 15, 18, 19, 20 like that. So, all those lines as many as possible. So, if we can list it, then in the next go the programmer may correct all those errors and then come up with the corrected version of the program. So, that way the programmer's life will be simpler. Otherwise, the programmer corrects line number 10, gives it for compilation and finds that again the compiler has given an error that there is an error in line number 15. So, that is not very much advisable. So, this error handling and recovery, so this is important. So, the recovery part will be clear when we go into the details of this error analysis job. Okay. So, it is not very much understandable now. So, there is a caution of course, that we should not think that all these modules are totally delinked from each other. It is not that the output of one module is given entirely to the second module, then the second module starts. So, it is not like that. So, there is not much demarcation between the modules and they work hand in hand interspersed manner. So, it is like this, that whenever syntax analysis phase, it will find that it needs some more words, okay, next word from the system, from the program. So, it will ask the lexical analysis phase to give it the next word. Similarly, when the code generation phase, so it will try to generate the code, it may ask the syntax analysis phase to generate the to give it, to tell it like what is the next rule by which I should proceed, what is the next grammar rule by which I should proceed. So, that way all these modules they go hand in hand. The later part like code optimization and also they are a bit independent, but say up to this intermediate code generation phase. So, I should say that they are all interlinked with each other. Okay. So, next we have this diagram actually depicts the whole thing, like your source language program, it enters into the lexical analysis phase. So, lexical analysis phase, so it does many things, like there are normally the source language program, they have got a lot of comments. So, the comments are removed because comments are never translated into machine code. So, they are removed from the program. Then between two words, somebody may put one blank, somebody may put 10 blanks like that. So, all those extraneous blank spaces they will be removed, and many times we have got some header files, we include some header files and we say that the compiler will for example, in C language we have got the hash include directive. So, they are all expanded. Okay. So, this all the expansion will be done by the lexical analysis phase. So, ultimately this lexical analysis phase, so it will generate some tokens. So, these tokens will be used by syntax analysis phase. Syntax analysis phase generates parse tree, which is used for semantic analysis, that if the program is semantically correct, then it goes into the intermediate code generation phase. Then from there the intermediate code, it is translated into target code, goes to target code generation phase, and from the target code it goes into optimization phase. And the symbol table management, it is used by all the modules from lexical analysis to code optimization. Some of the phases they will put entries into the symbol table, some of the phases, so they will use the values that are present in the symbol table. And there are error handling and recovery routines, so which will be which are integrated with all these phases again, and if there is some error that has occurred, so it will be trying to get some information from different phases and flash appropriate error message to the user, so that the user can correct the program in a better fashion. So, these are the different phases so by which the compiler generates the optimized target code from the source language program.